Hello students, in this video we'll discuss about computational languages and function. So in the last video we have discussed about construction of Turing machine for languages. But see, the Turing machine is not intended only for the languages. Even we can perform some computations, right? Like calculations, we can do that we will discuss. So first of all, Turing machine as a computational device. See, the Church-Turing thesis, we have discussed this in the first video of fourth unit 4.1. Every discrete mechanical process can be simulated by a Turing machine, which can be done with the computer, right? Or the mechanical process. So this claim has been justified by showing that Turing machine can simulate the operation of any interesting and reasonable model for the discrete computation. So how the computation is going to be done? So here we are going to have the two things. One is control unit and a tape. So the control unit is nothing but the set of states which belongs to the Q, and initially the starting state would be Q naught, which is mentioned in the tuple notation. And the tape is one-way infinite sequence. Sometimes it is two-way. We'll discuss about these types. And each cell contains a symbol from the tape alphabet. Then how the computation is going to be done? See, initially the tape starts with the Q naught, right? And if it is A, what we have to do with this Q naught, 0, whether we have to change it to something or where we have to keep, that you have to specify. After that, where we have to move, right side or left side or blank, then what is the operation you are performing? Okay, so that we are going to do it. Initially, the leftmost cell and the tape is separated by the blanks. Okay, all the cells are blank except the beginning of the tape, separated by the blanks. During the computation, we have discussed about this in the first slide also. We have to specify where it is and what we have to do with that symbol. After that, where we have to move and which symbol, right? So sometimes it may move left side, sometimes it may move right side. Sometimes from the first cell, by moving only left side, we can perform the task. Such concepts are called as partial functions. In the last example, what we have discussed, it was moving two sides, that is a full function. Sometimes we can just moving left side can perform the task, like one's complement. We'll discuss about that. But for the two's complement, you have to move both the sides, left and right. That comes under the full function. Let me just go with the one's complement. Let me tell you the situation first, how the one's complement is going to be done here. Right. So just listen here. If my tape is like this, assume that it is a one side open tape. As I told you, it can be infinite, depends on the situation. And the end of the input tape is denoted with the blank or delta, depends on the textbook. For example, if I'm having like this 0, 1, 1, 0, 1, 0, assume that this is my input. Then after performing the ones complement, so this is a initial configuration of the tape. Okay, initial configuration of the tape where the read write head is pointing to this, right? And the finite control unit will be having the set of states. So this finite control unit which controls the states and the head by moving it and changing the input tape symbols. Then after reading all the input symbols, the 0 has to be changed to 1 and 1 has to be changed to 0 and 1 has to be changed to 0 and 0 has to be changed to 1, 1 has to change to 0 and 0 has to change to 1. So while you are moving right side, if it is 1, change to 0, if it is 0, change to 1. So what could be the final configuration of my Turing machine? It would be like this. Same tape you can take it, right? So we'll be having 1 0 0 1 0 1 and delta. The head is moving to the final right symbol, that is blank, and the finite control unit, it was stating the current state QF. Initially it was Q naught. So it moved to the end and also final state. Then this is the output we got it. What is the input we have given? The input string is 0 1 1 0 1 0. That's the input. And what is the output we got here? The output is 100101. Now you should draw a Turing machine to perform this task, the ones complement. What we can do here? So simple logic here. See, if take a state Q0, if it is 1, change to 0, and after that move right direction, then don't need to change the state, because like you can do any number of 1s to 0 will be in the same state. Then same way Q naught, if you are be in the same state, then it may encounter 0, change to 1 and go on right side. Then don't change the state, because after zeros we can take 1, after ones we can take 0. That would be iteratively occurred. There is no such concept like earlier that you cannot take 1 A after B or B after A, like that. You can do, no problem, right? So then if you reach the final state delta or blank symbol, don't do anything, no need to move anywhere, simply you can go to the final state to accept it. That's it. So this is the IDs of Turing machines. Then how can we construct the table for this? Right, sorry, diagram for this Turing machine. It's very simple, guys. See, Q naught is giving the task to Q naught only 2 times, and one time it is giving the task to final state QF when it is giving delta delta no movement. Before that, if it is 0, change to 1, just keep on right side. If it is 1, change to 0, just keep on right side. That's it. This is the Turing machine to perform what? Ones complement of a binary number. Here we are not searching for anything. We are not moving left side. So this we can say that performing one's complement is nothing but partial function. Just from the initial cell we are moving only left side, we are not coming back. That's why we can call it as partial function. Let me just take this is the one. So 1 to 0, 0 to 1. Okay, we are coming back to the initial state, just initial state to accept it, but okay, that is not required here. They are making it as a full function instead of after going to the end they are again coming back to the initial state. So that's not required. Okay, that's your wish. There, as I told you earlier also, there is no only one way to perform any task. We have a number. Okay, now let me go with the twos complement, how we are going to perform it. See guys, for example, if my input is 101001 delta, so what is the ones complement of it? 010110, then delta. One's complement. Two's complement means just add 1 to it. Then you can write 010111 delta. 0 plus 1 1, remaining all are same. This is a two's complement. So how can we do this? Okay, just listen here guys. Q naught, first take the ones complement here. If it is 0, change it to 1, go on right side. If it is 1, change it to 0, go on right side. And if it is delta or blank, don't do anything, come left side. In the left side, if it is 1, sorry, if it is 0, change it to 1, and you don't need to move anywhere. If you want to move final state, that's your wish, right? I mean, it's a final symbol, but no problem, you can accept it. That's it. See, first perform the ones complement. When it is delta, go left side. If it is 0, adding 1 to 0 will be what? 1. That's it. But the problem is not this, right? You may have the problem with other symbols. Like for example, if it is 100, 100, 100, assume that this is the input. And what is the ones complement of this? 0110 delta. And what is the twos complement? You add 1. So 1 plus 1, 10 carry will be forwarded. 1 plus 1, 10 carry will be forwarded. 1 plus 1, 10 carry will be forwarded. 0 plus 1, 1, and you can write the remaining all are as it is, right? So what will be happen here? See, you have to perform the ones complement, then addition. See, when you come left side, you cannot perform the directly 0 to 1. if it is 1, what you have to do? We have to add by 1. It would be 1 0. Carry will be forwarded. Like the carry will be forwarded till which symbol? That you have to identify. See, if it is 1, 1 is changed to 0, carry will be forwarded. 1, 1 is changed to 0, carry will be forwarded. 1 changed to 0, carry will be forwarded. So carry will be forwarded until 0. Whenever you get the 0, then the answer would be end. So now the Q1 should search for the 0 in the left side. The Q1, after coming back to the delta, when you are going back, you should search for 0. Until 0, if it is 1, change to 0, go on left side. Because carry will be forwarded. 1 plus 1, 1, 0, 0, carry will be forwarded to the next left symbol. Like that. So this is how we are going to perform 2's complement. And this is one way. The another way is 2's complement is, right? So you search for the, go to the end. From the right side, search for the first one. Right? Search for the first one. So when you got the first one in the back side, then perform the 1's complement of remaining. That's it. That's the answer we got here. 10001. So from the right end, simply go to the last symbol. From the end, search for the first one. Whenever you get the 1, perform the 1's complement of previous symbols. That's how it is going to be done here. See, first search for the end, 0, 1, 1 or blank. And in the, when you go to the end, in left direction, search for the 1. Until 1, make all the zeros to L. You got 1. Whenever you got the 1, 1 L, then you perform the 1's complement until you get the first symbol, that is initial symbol, BBR. That's it. Same thing. What I did it in one way, they have done in another way. Both are correct. Both will give you the same results. Okay. So in the next video, we'll discuss the techniques for construction of Turing machine.